Hello students, in this video we'll discuss inverse functions of functions of a real variable. We consider a function f which maps r into r. We say that f is 1-to-1. Sometimes I'll just write 1-to-1, or we also call 1-to-1 being injective. If, whenever f of x is equal to f of y, we have that x and y are the same value. Okay? So let me give you two examples of functions, one example of a function which is injective and one which is not injective, okay? So if I look at this, so here are some examples. So if I look at f of x, which is the square root of x minus 4, I claim this is 1-to-1, okay? And how can I see that? Well, I can check if x minus 4 is equal to what? Is equal to the square root of y minus 4. You can eliminate the square roots by squaring both sides. You can get x minus 4 is equal to y minus 4, which implies that x is equal to y, okay? Whereas, now of course means that f is injective. Of course, there's no extraneous solutions over here too, because I can double check that. That will clearly work over here, okay? The second example we'll do, let's do this function over here. This is a quintessential example of one which is not injective. So g of x, which is x squared, is not 1-to-1. So it's not injective. And why is it not injective? Because if I look at g of 1 is 1 squared, and g of negative 1 is 1 squared. So we have that g of 1 is equal to g of negative 1. So g of 1 is equal to g of negative 1, but that's clearly not the case that 1 and negative 1 are the same. So this function is not injective, okay? Now, injective functions are great because injective functions, or these 1-to-1 functions, if I consider them as functions from their domain onto their range, have what's known as an inverse function. So we say, so here's the definition, we say that g is the inverse function of an injective function f. If two things are true, I need two statements to be true. If one, f of g of x is equal to x, and two, g of f of x is equal to x. Okay, so let's see an example of, so in other words, I would like to find a function that has this property over here. So in other words, I'd like to find a function. So let's try to find the inverse function of this function over here, right? So what would we like to have happen? If we want to consider this function, the function we just have above, right? If we have f of x, which is the square root of x minus 4, what do we want? I want g of x, so I would like to plug in a g of x to this expression and get the square root of g of x minus 4. And I'd like this to output x, And so I can figure out what this g of x is by solving this equation over here. So if I solve this equation over here, what I'll get is I'll get g of x minus 4 is equal to x squared, and therefore g of x is equal to x squared plus 4. So let's test and see if this function g actually does the trick, okay? So by construction, what's happened over here? By construction, when I plug this g of x into the function, I get what? So we have to be a little bit careful now. So let's check to see if this is a good candidate. But if I look at, let's do two things first. Let's first look at g of f of x. G of f of x is going to be what? So g of f of x is going to be, so we're going to plug in f to g. So that's going to be the square root of x minus 4 quantity squared plus 4. Well, that's clearly going to be what? That's clearly just going to be x minus 4 plus 4, which is just equal to x. That's great. And then as we saw over here, what's f of g of x? Okay, so f of g of x will be what? Well, f of g of x is going to be the square root of x squared plus 4 minus 4, right? And that's just going to be the square root of x squared. And so herein lies a little bit of the difficulty, because the absolute value of what? The square root of x squared is just the absolute value of x. So this would be equal to x if x is what? If this x is positive over here. So I would like this expression over here to be not negative, right? So this is x if x is greater than or equal to 0 over here. So we have to figure out what the natural domain of this thing is over here. So let's think about what f is doing. So f is going to map what? It's going to map the interval 4 to infinity into what? That's its domain, into 0 to infinity. But this function g is a domain of everything, so what we have to do to make sure that we don't get this situation over here is we have to restrict the domain of g to this over here. So I would like g to map what? 0 infinity into 4 plus infinity. So what we're going to do is we're going to modify our definition of g. So this is the good candidate. It's the candidate with one modification that's required, and the domains are very important here. So the condition we need on g is our inverse function of this function f, which we're going to write, and one thing we didn't write is oftentimes what we'll write for this function g is we'll write this as f inverse. So our function our actual inverse function f inverse of x, the function that g really should be, is it should be x squared plus 4 with the condition that what? That x is greater than or equal to 0. So it's important to find the candidate function first. You find the candidate for the inverse function. You verify that both conditions are satisfied, that condition 2 and condition 1 are satisfied, and then you make sure that you're respecting all the domain restrictions and all the range restrictions which the original functions impart upon you. Thank you very much.